Like I mentioned in the last unit's video, math is oftentimes a lot about finding shortcuts to get the same amount of work out. And sometimes if you have multiple functions and you're trying to get to an end result, it's easier to combine the functions together into one single function versus having to work with multiple functions to get to the same spot. So this section is going to revolve around combining functions together and the different ways that this can be done. Our very last objective today will look at going the opposite way, breaking a function apart. But before we get to any of those objectives, we're going to focus on this first one here, which is looking at the domain of a function again. So when we talk about the domain of a function, remember the domain is like our input, or like our x's, everything that x can be. So if they give me a function and they want to know its domain, I tell people sometimes it's easier, rather than trying to figure out everything that x can be, especially if you don't have the graph in front of you, it might be quicker to figure out what x cannot be and then just throw those numbers out. So there's two issues you want to watch out for. You want to watch out if the function has a denominator with variables in it, and you want to watch out if the function has variables under a square root. Those are the two places you want to be careful of. If the function has neither of those issues, then you're golden. So like if we look at this first one, and I said find the domain of this function. Does it have a denominator? No. Does it have any square roots? No. So what that means is I don't have to worry about throwing any x values out. So all x's are acceptable for this function. I can plug any number in for x and get an answer out. So since all x's work, I don't have to throw anything out. My domain would be everything, negative infinity to infinity. Now let's look at the next one here. The next one does have a denominator. And the reason why we have to be careful with denominators, what number can I not divide by? 0. So I have to figure out, are there x's that would make that denominator come out to 0? Because if there are, I have to throw them out. So to figure out what would make the bottom 0, let's just set the bottom equal to 0 and solve it. Let's figure out what makes it 0. So if I factor this, I want to multiply to negative 3, and I want to add to negative 2, so two numbers that do that. Negative 3 and a positive 1. So it would break into x minus 3 and x plus 1. And if I set each piece equal to 0 and solve, I get 3 and negative 1. So what those numbers represent, I'm going to draw a slash. Those are the two x's I do not want, because if I plug either of them back in, I'm going to get 0 on the bottom, and I cannot divide by 0. So what this tells me about the domain is every other number will work, but not 3 and not negative 1. But I can use everything else. So when I write my domain, the smallest I could go, I could keep going all the way into the negatives. I could use negative 80 if I wanted. It would be okay. I'd get an answer out. And as I work my way up the number line, when I get to negative 1, I'm going to throw negative 1 out. Now I want to use a parenthesis with negative 1 because remember that means I'll go all the way up to negative 1, but I don't want to include negative 1. And then I'm going to use my OR symbol, and I'm going to pick back up at that thrown out value, and now I'm going to continue working my way up the number line, so I could use 0, 0.1, 1, 2, but when I get to 3, I have to throw it out, or I'll pick back up, and then anything after 3 works, because I didn't have to throw anything else out, so I'll keep going. So it looks like a mess, but this is my domain. So if I saw this as a math person, I would say, okay, it looks like I can use any value of x that I want, but I can't use -1 and I can't use 3. Everything else is okay. That's what that means. So obviously, the more numbers you throw out, the more pieces your domain is going to be broken into. Let's look at the next one. I have a square root. Now, the reason why we have to be careful if square roots are involved, I run into issues if I take the square root of negative numbers, because remember the square root of, like, I don't know, square root of -4 would be 2i. It'd be imaginary, and I want real answers out. So when you're dealing with square roots and you want to find the domain, you have to ask yourself, is there any number for x that would make this inside come out negative? The simplest way to figure that out, besides guessing and checking, is to take the inside and set it greater than or equal to 0, which I'm basically telling it, hey, I don't want you to come out negative. So if I solve this just like I would an equation, I'm going to subtract 12 and then divide by 3. My symbol does not flip because I didn't divide by a negative. So what this means is, hey, if you want the inside to come out to 0 or bigger, your x's have to either be -4 or greater. So if I turn that into interval notation, greater than or equal to -4, I want anything bigger than -4. And I'd want to use a bracket, because if I plug -4 in, I'd get -12 plus 12, which is 0, and I can take the square root of 0. But notice if I go outside of that, if I were to say, oh, I'd like to use -5, if I plug -5 in, I'd get -15 plus 12, which is -3, and I'd have to take the square root of that, which is imaginary. So this is my domain. -4 on up would work. Anything else? No. And the last one is a double whammy, because I have a square root and it's in the denominator. So what we're going to do is we're going to take that square root and we're going to set it greater than 0, but this time I don't want to also be equal to 0 because I don't want the bottom to come out to 0. So I'm basically telling it, hey, keep the square root positive, but also I don't want it to be 0. So let's solve. I'm going to subtract 14 over, and then I'm going to divide by -2, and when I do that, the symbol has to flip, and I get x is less than 7. So turning that into interval notation, that means I have to stay under 7, and I'd want to use a parenthesis with 7, because if I plug 7 in, it actually makes the bottom 0, and I don't want that to happen. So that would be my domain. That's probably going to be the trickiest thing today. The rest shouldn't be too bad. So now what I was talking about earlier, sometimes it's easier just to combine functions together. So if I want to find the sum of two functions, so if I wanted to find this, the sum of f and g, all I would do is take f of x plus g of x. I just add them together. If I wanted to find the difference of f and g, all I would do is subtract them. Now make sure if it's f minus g that you do f minus g. If I want to find the product, that's multiplication. I would just take f of x times g of x. And if I wanted to find the quotient, that's division, I would have to take f of x divided by g of x. So if it's f over g, then you need to make sure you do f over g. Let's try it. So let f equal 2x minus 1 and let g equal x squared plus x minus 2. Find each of the following. So the first one wants me to find them added together. So I'm going to take f plus g. And now all I want to do is combine like terms. So I'd have an x squared, 2x plus x, I'd have a 3x, and negative 1 and a negative 2. There would be my simplified function, the combined function. I don't want to solve it, I just want it simplified. Okay, let's do the next one. So f, 2x minus 1, minus g. Now this is where people mess up. We need to make sure with the subtraction that I subtract the entire function behind it. So I'm going to keep it in parentheses, because what's actually going to happen, I would have my 2x minus 1 minus x squared minus x plus 2. It's like that subtraction has to distribute. And then I'll combine like terms. So I'd get a negative x squared, 2x minus x would be 1x, and negative 1 plus 2, I'd get plus 1. So there would be the subtracted function. The next one wants me to multiply them. So I'm going to take f times g. So to multiply these, I'm going to have to manually distribute. So I'm going to take my 2x and multiply it through. 2x times x squared, I would get 2x cubed. Remember, we add the exponents. 2x times x would be 2x squared, and 2x times negative 2 would be negative 4x. Now I'm going to take the negative 1 and multiply it through. So negative 1 times x squared, negative 1 times x, and negative 1 times negative 2. And now I want to combine like terms. So it looks like I have only 2x cubed. 2x squared minus 1x squared would be x squared. Negative 4x minus x would be negative 5x. And then plus 2. And the last one wants me to divide them. So I'm going to take f divided by g. Now you'll like this. I can't do anything with this, so that is the answer. That cannot be simplified. I can't cancel or reduce anything. So now this bottom question says, find the domain for each function. So remember, domain is like the input, everything that x can be. Watch out for denominators, watch out for square roots. So this first guy, if I look at my answer, x squared plus 3x minus 3, does it have a denominator? No. Does it have square roots? No. So I don't have to throw any x's out. If I don't have to throw anything out, that means everything works. So the domain for this guy is negative infinity to infinity. Everything is okay. The next one, do I have any denominators or square roots? No. So everything works. All x values work. Next one, same thing. I didn't have any denominators or square roots. Now, unfortunately, the last one does have a denominator. So down here, I have to figure out what makes that bottom 0. So I'm going to quick set the denominator equal to 0, and we're going to solve it. Let's factor it. So I want to multiply to negative 2, add to positive 1. So I'd have to do a 2 and a negative 1. If I solve, set each piece equal to 0 and solve, I come out with negative 2 and positive 1. Those are the two numbers I do not want. They make the bottom 0. I do not want them. Everything else is good, but not those. So when I write my domain, it'd be negative infinity until, which one would I run into first? Negative 2, because I'm working my way up the number line. Or negative 2 until 1, or 1 onwards. That would be my domain. All right, next item is an application problem, which if you can do what we were just doing, the application problem isn't that bad. The functions below model the number of births and deaths in the US from 2000 to 2011. So B is the number of births, and D is the number of deaths. Write a function that models the change in US population for the years from 2000 through 2011. Well, if I want the change in the population, I have to take into account the people being born and the people dying. So what would I do with those two quantities? Hopefully you should say we are going to, I want to find this. Right? My births, but minus the deaths, that will give me the change in population. So I'm going to take the birth function and I'm going to subtract the death function. But make sure it's in parentheses because we have to make sure this subtraction applies through to everything. So if I do that and I combine my like terms, I would have negative 2.6x squared plus 0.6x squared, 49x minus 7x, and 3,994 minus 2,412. So that function would give me the change right away instead of having to use two different functions. So part B says, use that to find the change in US population in 2008. So I'm going to be substituting in, but I don't want to plug in 2008. Notice up top it said my X is the years after 2000. So I'd want to substitute 8 in. So anywhere I see an X, I'm putting in an 8. And then I want you to simplify that and we'll have our answer. So if you were to do that math in your calculator, you should get 1,790. Now what is this? What is its label? Well, technically they said this is in thousands. So what this would mean, or what this would represent, since that is taking into account the births and the deaths, and it came out positive, we actually have an increase in population, meaning more people were being born than dying. There is one other way that is sometimes handy to combine functions, and it's called composite functions. And the symbol for composite, it looks like a little ring. So that's read as F composed with G. So literally what that means to do, if you see that symbol in math, it means you're going to take F, but you're going to substitute G into it. So I tell my students, when they see that symbol, I want you to think eats. So this literally means F eats G. It's not the most mathematical term, but it sticks with people. G ends up inside of F. The other one, if I saw G composed with F, that means I would take the G function and it would eat F. F would end up inside of G. So let's try them. So given that F is 3x minus 4 and G is x squared minus 2x plus 6, find each of the following. So F eats G. I'll color code it. So we are going to take the G function and we are going to substitute it into the x's of the F equation. So here's my F equation. But instead of x, I'm going to replace the x with the g equation. So I literally substituted g into f. And now I would just like this simplified. So let's distribute. So 3x squared minus 6x plus 18 minus 4, and combine like terms. So this is the result of f composed with g. I don't want you to solve it, you're just simplifying it and stopping. Let's look at the next one, g composed with f. So this, I want you to think, g eats f. So this time we're taking the f function and we're substituting it into the x's of g. So here's my g equation. But instead of the x's, I'm going to replace the x's with the f function. Notice there was multiple x's, so I had to replace it multiple times. And now I want to simplify this. Because this first quantity is squared, I'm going to write it twice. That's what the squared means. I'm going to bring everything else down. So we're going to have to FOIL. First times first, 3x times 3x, 9x squared. Outer times outer, 3x times negative 4, negative 12x. Inner times inner, another negative 12x. And last times last, negative 4 times negative 4, 16. Next set, I'm going to distribute my negative 2. And then don't forget about the plus 6 at the very end. And now combine like terms. So I'll have 9x squared. Now let's combine all of the x's. So negative 12, and negative 6. Negative 30x. And then 16 plus 8 plus 6 plus 30. There would be the composed function. And now look at this very last one here. It looks exactly the same as the one we just did, but sitting in x's spot is 1. All that means then is we are going to plug 1 in for x. And we already know this answer, g composed with f. That's this guy. So to get this last answer, I'm just going to plug 1 in. I'm going to get a number out. So notice I would get 1 squared is 1, 9 minus 30 plus 30. If I combine all of those, I get a value of 9. So all it wanted me to do was to substitute in. All right, and the very last thing for today is going the exact opposite way that we just did, and that's decomposing functions, breaking them back apart. So what I tell people when we do these, when you're breaking them apart, I want you to look for an inner and an outer function. So here's what I mean by this. If I had something like the cubed root of x squared plus 1. Let's say that was my function. And I asked, okay, break that back up into two functions. And when you break it up into two functions, I want this to be true. F eats g. So what I would tell people then, since g has to end up inside of f, g should represent like the inside. So if I look at this function, what's inside? Well, x squared plus 1 is inside of the cubed root, so let's try that. If I let g equal x squared plus 1, then f would have to be everything that's left, or like the skeleton. So it would have had to have been the cubed root of x. Now, if I wanted to check, did I break it up right? If I asked you to take G and substitute it into F, would you get this? And the answer is yes, you would. So we're just breaking it back apart. We're doing the exact opposite of what we just did. So let's end with this example. Write the function h as a composition of two functions. So I want to break it back apart into two functions. And again, I'm going to say I want this to work. F composed with G. I want that to be true. So let G be the inside piece. Now there's more than one way to do this one. So I would say, what's the inside piece? You might say, oh, x minus 2. I'll say, okay, that would work. So then F would have to be everything that's left, the skeleton. So 1 over x squared. And if you wanted to check, if I substitute this in for x, would I get this? And you would. Or you might have taken another route. This would also work. So this is one answer. You might have also said, what if g of x was this? The entire bottom. That could work, but then what would the leftovers have to look like? Well, it would have to be 1 over x. And then hopefully you see if you substitute this into the bottom, you would still get the same answer. So some of these do have more than one way to do them. I would just double check them at the end to see if it's correct.